Hey kids, welcome to another lesson. This is Module 2, Lesson 17. And so the very exciting thing that we are getting ready to do is to do long division with larger numbers. And so before we can jump into long division with larger numbers, we need to have some skills. We need to develop our rounding skills and our guessing skills so that long division will not be so challenging. So let's take a look at the objective. It's use basic facts to approximate quotients with two-digit divisors. So we've been using single-digit divisors. Now we're going to have bigger numbers as our divisors. Remember, you should know which one's the divisor and which one's the dividend. Now, take a look at our first problem. Let's say you have 402 divided by 19. 19 is the divisor. So as you can see, we have a very important message for today. And so I'm going to take apart this objective and we're going to make it kind of simple for you. The first thing you're going to do is you're going to round the divisor. Now the divisor is going to be in this format, the second number. And in a bracket format, the divisor is on the outside. Now in your mind, you're going to be rounding this when you do long division. It's all going to kind of take place in your mind. But today, we're learning how to make this happen and how to be really efficient with your rounding. So when you round the divisor first, the next thing you're going to do is find a compatible number. A compatible number is like a buddy number. They hold hands. They are good friends. A compatible number is an easy, quick fact. Something that you can skip count by, a quick fact that you know it's a multiple of this number. So our rounding may not go the way of normal rounding now. And again, do not start with this number, start with this one. So for example, if I have 19, I would round to 20. And then when I look at 402, whatever I round it to, I want it to be a multiple of 2 or 20, same thing, that it's easy to like skip count by, okay? And I want to have kind of an exact answer. If you take a look, 40 is a multiple of 2. And so then I would proceed with my simple division. If I have 40 divided by 2, you're going to get 20. And so then looking at my exact answer over here, when eventually we do the exact division, which we're not doing today, you'll be able to see how our estimated quotient is going to tie in with our actual quotient. A couple more examples on the back that are really helpful, and it's kind of to caution you. So look at this next problem, 149 divided by 71. Round the divisor first. When you round 71 to 70, you're going to have 7 as the number that you will skip count by. Now, if you look at 149, students will say, I want to round it to 150. I want to round it to 150 real bad. And I would say, that would be great if we were rounding exactly. But today, the purpose is not to round exactly. The purpose is to help us with long division to get a quotient that's reasonable. And so I don't want to round to 150 because 15 is not a multiple of 7. I want to round to a multiple of this divisor number. So that's when we're going to take 149 and make it 140. Really looking at these first two numbers as the multiple of my single digit over here. So since 14 is a multiple of 7, I can change 149 to 140 to get this easy calculation to get the 2. Okay? I wouldn't want to round 149 down to 100 and use 70 because a lot of kids are still like, oh, I just want to use all the hundreds. I'm just going to round everything to 100. Well, 10 is not a multiple of 7. So this is not an easy fact. That's not an easy fact. 14 divided by 7 is an easy fact. Here's another example. Rounding the divisor first, round 58 to 60. We want to use a number for the dividend that is a multiple of 6. Always look at the first digit or 2 to see what is a multiple of this number. Since 427, see again, students will say, well, what about 430? 43 is not a multiple of 6, but 42 is. So if you round it to 420, then you can start your division. And like in the previous lesson, then we have these offsetting zeros. You can slash those out, and you have 42 divided by 6 for 7. Now, why are we doing all this again? Because in long division, when I get this number, that's what I would put in the quotient. Okay? Another little cautionary thing, don't round the dividend. The dividend is the first number. You're not going to round it like we normally do. You're not going to follow any rules. You're not going to say, well, if it's 5 or greater, it goes up, and if it's 4, 3, 2, 1, it goes down. Don't do that. Not today. We will find a compatible number using numbers from the fact family, something that you can skip count to from this number here. Okay, I hope that's really clear. I actually have more notes on this because it's such an important thing that you round the divisor first today and every day when you're doing long division. Okay, so the divisor is again on the outside, or it's the second number in the problem. The whole is what's being shared, and this is what you just kind of want to ignore that until you come up with a rounded divisor. Obviously, we would round to 20, and then you could proceed with any number that's a multiple of 2. Okay, if you wanted 400, that's fine. If you wanted 420, that's fine too. It just depends on how hard you want to think. Okay, so let's put those notes away and jump into the book. It's actually really easy once we get going. Okay, you're gonna like it. You are gonna like it. All right, so the directions. Estimate the quotient for the following problems. Round the divisor first. Look how important it is. They are telling you here and there and everywhere. Round the divisor first. This is the divisor. Okay? So once you round the divisor to a number that you can easily skip count by, make sure this number is a multiple of it. Then apply lesson 16's strategy of the offsetting zeros. Remember, I said make a match. If there's 1 here, then you get to slash out 1 here. If there are 2 here, then you get to slash out 2 here, but you have to make them match. So here there's only the 1, and then you end up with 60 divided by 2, which would then be 30. So that's your sample. So what are you going to do here? Round the divisor first. Good call. So when rounding this, and you round to 30, they start us off nice and easy. I want a multiple of 3 that is really close to this. So easy peasy. Use 900. Look at those zeros. So it's round the divisor, find a compatible number, look for matching offsetting zeros. This is where we would divide both by 10. So 900 divided by 10 divided by 3. And then we can have our simplified problem of 90 divided by 3. 9 divided by 3 is 3, and the 0 comes down. Okay? Easy peasy. A lot of talking, but we'll simplify it. Round the divisor first. 37 rounds to 40. Then I need a multiple of 4 that's close to 826. I'm just going to keep it simple here. Use 800. Offsetting zeros, and then we have 8 divided by 4 is 2. Bring down that 0. See? See how easy it is? You're like, oh my gosh, I totally get it. And then you say, oh my gosh, I totally just said that. How did she know? Okay, so 73, round the divisor first. Let's take it to 70. Then I need a multiple of 7. Now these had single digits and nothing but zeros. Now I have 14 as a multiple of 7. Now I want to keep that 14 there, but change the 1 to a 0. So instead of 141, round it to 140. Now I have a nice compatible number that is a multiple of 7. Divide both sides by 10, so slash off those zeros, and then 14 divided by 7 is 2. See how it's starting to get really easy? Round the divisor first. 58, how about 60? I need a multiple of 6. A multiple of 6, look at the first 2 numbers. Make sure you have 3 digits. So a multiple of 60 that is very close to 241. Use the 24, change it to 240. Instead, divide both sides by 10, and then you have 24 divided by 6, which is 4. Knowing your facts is very, very important here. 62 is our divisor. Let's use 60. Then I need a multiple of 6 that's close to 482. Knowing your facts, you should know that 48 is a multiple of 6 because 6 times 8 is 48. Divide both sides by 10. That leaves you with 48 divided by 6, which is 8. Next one. 81, round the divisor first. Change that to 80. Now I need a multiple of 8 that is close to 656. Now we're not as easy. They've given us these multiples that were already existing in the number. But 65 is not an even multiple of 8. So now you have to start thinking a little bit. I can't round this in a way that, you might want to. You might say, what about 700? 700! But no, you don't want to just round to the closest hundred. You want a multiple of 8. So if you count by your multiples up till you get into the 60s, okay, then you might recognize that 64 is a multiple of 8. And so then you want to use 640 instead of 656. So you have to find something that is a multiple. Just ignore the regular rounding rules. Once you get your compatible number, divide both sides by 10, and then do your regular division. Here's where sometimes, instead of having the exact same number of digits like we did up here, you might have to bump it up because 99 really is close to 100. And 799 is also really close to 800. So that one's pretty easy. But look at what we created. We have 2 zeros on both sides. That means it's matching 2 and 2, which leaves us with 8 divided by 1 for 8. Okay? And when we have something in the middle, what if you wanted to go up to 100? And what if you wanted to go down to 90? Well, it's really up to you. When you round the divisor first, you should be thinking about what multiple of these numbers is closest to the first 2 digits in your dividend. So you really have to think about what number should I choose that is closest to these 2 digits. So now you have to really slow down and not just round the divisor first to anything. You have to round the divisor to something that will work with these digits. Now 63 is a multiple of 9. So 90 is a better estimate. Remember how I was talking about the bestimate a few lessons ago? Okay, 90 is the best estimate because 63 is a multiple. I could change this whole thing to 700 divided by 100, and I'm going to end up with a really nice answer as well, so I'll show you in a second. But let's change this to 630 so that I have the 63 and then the 0, and then I have offsetting zeros, so divide both sides by 10. 63 divided by 9 is 7. But also, if you chose to use 700 divided by 100, what would you get? And you would get 7 there as well. So sometimes when you're estimating, you may have a different guess than a neighbor, and you're both going to end up with pretty good answers. And remember, with estimating, there can be more than one right answer. In fact, the answer key usually says, estimates may vary. Oh, I hope I don't lose my lead here. Okay, round the divisor first. Oh, yep, there it goes. Maybe we'll have another one that is ready to go. Yay, more lead. Round the divisor first. Let's make it 80. So I need a multiple of 8. And look at, they did not give us something that is a multiple of 8. So know your 8s. And what is a multiple of 8? 8, 16, 24, 32. So I want to use 32 instead of 31, but hold that last spot with the 0. 3 digits here, 3 digits here. Now I have a multiple of 8. Divide both sides by 10, and then I have a simple problem, 32 divided by 8 for 4. Hooray. Round the divisor first. Make it 80. I need a multiple of 8. Easy peasy. 64 is a multiple of 8. Offset the zeros. Divide both sides by 10. Divide. 35. When you're in the middle, you can go up or down. So think about what the first 2 digits are here. If I go down to 30, does 3 have a multiple close to 14? If I go up to 4, for 40, does 4 have a multiple close to 14? So this is where students are going to have lots of different answers. If you use 30 for your multiple, so let's say I choose 30, then I have to have a multiple of 3. So 3, 6, 9, 12 could be one option, or 15. Okay, and that would work for both, for 30. But if I have 40 as my estimated divisor, then it has to be a multiple of 4, which could again be 120 or 160. So it has to be a multiple of 4 for your first 2 digits, okay? So let's say I have my offsetting zeros and then I divide 12 by 3, I would get 4. And if I did the offsetting zeros here, I would get 5. So 4 or 5, or 5 or 4, however you look at that. But what if I use this one? Then what would my quotient be? So offset the zeros, 16 divided by 4 would give you 4, and 120, or 12 divided by 4, would give you 3. So your estimated number that you would put into your quotient if you were doing a long division problem that was 143 divided by 35, it's to just get close. Now, some estimates are going to be closer than others, and one of them is going to be right, and the other 2 will not actually work well, and you'll have to change it and come up with something better. But you're within a couple of digits in your quotient, so you would guess either 3 or 4 or 5. Okay? All these are going to be fine. So again, look at what you have for your options. If I have 52 as my first 2 digits, and I round this to either 20 or 30, or what if I just left it at 25, knowing that 500 or 50 is a multiple of 25? So you have a lot of different options here. You could use 20, you could use 25, you could use, really even 25 would be excellent. What if you use 30? Let's just stick with, say, 20, and we could try 500, because that's going to be 50 would be an even multiple of 2. 25, again, you can use 500, but you can also leave it at 525, because this is actually a multiple of 25. Remember, when counting by 25s, you would have the 0 or the 100, and then 25, 50, 75, and then the 100. And 30 would be much more challenging, because then you have to think, well, what am I doing, and which one carries over? Should I raise it up to 600 so it's a multiple of 3? And that could be a change where you might be a little too far away. So anyway, if you use your offsetting zeros here, then 50 divided by 2 would be 25. If you have your 525 divided by 25, then it would be 420 to 120 right there. Sorry, I'm just thinking out loud. And then if you offset these zeros here, you would have, again, a 20. So good estimates would be a 25 or a 20 or a 20 for any of those. And probably students will come up with all of these, and that should be allowed, and it should be okay. And the next one. If you round the divisor first and you look at what could be a multiple that is close to this number, you might want to use a 9 for 90, because 54 is actually pretty close. So notice that I went up for this one and I went down for this one, and we're really just trying to get close to, or have a reasonable guess that we can put into our quotient. Divide both sides by 10 and I get 6. Another one, also thinking about not just single digits, but if you know your 11s, then you can leave this at 11 and do 660. Perfectly acceptable way to do these problems. This does not have offsetting zeros over here. Okay, you can't slash anything here because there's no mate. Remember, you have to have a partner. And so 66 divided by 11 would give you the 6, but then you can't forget to bring down that 0. All right. Only a couple of word problems today. It's a pretty short lesson. A video game store has a budget of $825 and would like to purchase new video games. If each video game costs $41, estimate the total number of games the store can purchase with its budget. Explain your thinking. So if our total budget is $825 and each video game is $41, then this is how we would set it up, because total divided by the cost for one. So we want to have how many games, but these numbers are difficult to work with. Let's make it easier because we're estimating. What do you do first? That's right, round the divisor first. What do you do next? You come up with a compatible number that is a multiple of your divisor. So if I look at this 82 and I just say, you know what, 800 is pretty close. That's going to give me a really nice, easy problem to work with, so that I end up with 8 divided by 4 for 2, and then don't forget that other 0. And this is asking about games. And so we end up with 20 games, or approximately about 20 games can be purchased. Okay, now if they ask for exact answers, then you have to do tax and spend a little bit more time. But today we're just estimating. And also, click subscribe, come back again. I will try to be real helpful with these videos, especially word problems. And the last problem, Jackson estimated 637 divided by 78 as 640 divided by 80. He reasoned that 64 tens divided by 8 tens should be 8 tens. Is his reasoning correct? If so, explain why. If not, explain why. And explain a correct solution. So if you take this 637 divided by 78, and you round the divisor first and you get your 80, and then you round this and you have a multiple of 8, you would probably look at that and say 640, and you'd say, all right on, Jackson. That looks good to me. Let's work it out. Divide both sides by 10, and what do you notice? You notice that you have 64 divided by 8 for 8. Well, that's 8 ones. Okay. If I had 64 tens divided by 8 tens, if I put that in standard form, 64 tens is 640. Remember, it's like 64 times 10. Divided by 8 tens, well, 8 tens is 10 times 8, which is 80. Okay? Now, if I end up with tens divided by tens, it's like saying 10 divided by 10. Well, what's 10 divided by 10? It's 1. Hence the label. Okay? So tens divided by tens are ones. Tens divided by tens are ones. The reasoning here, it's not going to be 8 tens. That would be incorrect. And so the correct solution is that tens divided by tens are ones. Tens divided by tens make ones, not tens. And then you just proved it right here. So I hope these are helpful, and come back again and we'll do another video. See you soon. Bye.